Hey Savvy people, it's Savvy Nick here, and today I plan on continuing with the Python tutorial on python.org. We are on Chapter 9, Classes, so this is going to be a nice stream where we get to learn about object-oriented programming, or at least how to set up some classes here. Last time we went through exceptions and how to handle them, and today we'll just go through classes here. If you're new and stopping by to watch this stream today, please make sure to subscribe below and hit the notification bell for future streams. What I'm going to do is just read through the beginning here. So classes provide a means for bundling data and functionality together. Creating a new class creates a new type of object, allowing for new instances of that type to be made. Each class instance can have attributes attached to it for maintaining its state. Class instances can also have methods defined by its class for modifying its state. So this is just a convoluted way of saying that you can create your own type of structures that can have functions as well as variables that are tied directly to that structure, and you can actually create multiple structures that are all independent of each other, unique to each other, but follow the same kind of form, really. Hey Matsu, nice to see you again. Thanks for stopping by. So sometimes classes can become overcomplicated in some languages, but we'll try and make this as easy to understand as possible. So in comparison to some other languages, really all this paragraph says is that they're going to go ahead and try using C++ as something to reference off of as far as how object-oriented programming works in there and compare it to Python. They say that it works better. A better comparison is actually to Modula 3, but I've never even heard of Modula 3, and they even make a joke of it down here where they say they would use Modula 3 terms, but very few people have probably even heard about it. So in C++ terminology, normally class members, including data members, are public, except below private variables, and member functions are virtual, as in Modula 3. There is no shorthands for referencing the object's members from its methods. The method function is declared and with an explicit first argument representing the object, which is provided implicitly by the call. As in Smalltalk, classes themselves are objects. This provides semantics for importing and renaming, unlike C++. In Modula 3, built-in types can be used as base classes for extension by the user. Also, like in C++, most built-in operators with special syntax, arithmetic operators, subscripting, etc., can be redefined for class instances. All right, so we'll move down and talk about a word about names and objects. Objects have an individuality and multiple names in multiple scopes. Can be bound to the same object. This is known as aliasing in other languages. This is usually not appreciated on a first glance at Python and can be safely ignored when dealing with immutable basic types, so numbers, strings, and tuples. However, aliasing has a possibly surprising effect on the semantics of Python code involving mutable objects such as lists, dictionaries, and most other types. This is usually used to benefit the program, since aliases behave like pointers in some aspects. For example, passing an object is cheap since only a pointer is passed by the implementation. And if a function modifies the object passed as an argument, the caller will see the change. This eliminates the need for two different argument passing mechanisms as in Pascal. A lot of these paragraphs here don't give you too much unless you know about the language that they're actually talking about, and they really pick two that one, never even heard of and probably not that popular, and then two, one that's been deprecated. I mean, Pascal used to be used quite often, but not nowadays. Hi there, Technical Lightesh. Nice to see you. I'm glad to have you here. We're just reviewing classes in Python right now, kind of going through tutorials. I hope everyone's doing well, and I'm glad that you made it on to watch today. Continuing on here, Python scopes and namespaces. Scopes and namespaces can get confusing sometimes, at least in C and C++ they do. So let's go ahead and read through some of this. I don't think I'm going to go through every single word in this extensive essay, but we'll get to the example here soon. Let's see. So before introducing classes, they want to show us something, just really some rules. And this is very useful for Python programmers, especially advanced ones. So they begin with some definitions. They say a namespace is a mapping from names to objects. Most namespaces are currently implemented as Python dictionaries, but that's normally not noticeable in any way except for performance, and it may change in the future. Examples of namespaces are the set of built-in names containing functions such as absolute and built-in exception names. The global names in a module and local names in a function invocation. In a sense, the set of attributes of an object also form a namespace. Gotcha. The important thing to know about namespaces is that there is no relation between names in different namespaces. For instance, two different modules may both define a function called maximize. Without confusion, users of the module must prefix it with the module name. Well, thanks. Thanks for that, technical. I appreciate that. So really, just to boil this down is if you want to access a function and there's multiple modules with the same function, in order to not confuse you, you have to use the module name as a prefix, and I'm sure it's module name dot whatever. By the way, I use word attribute for any name following a dot. All right, so whether or not it's a function, I assume, or a variable, this tutorial is referencing it as an attribute. So we'll just keep that in mind. So attributes may be read-only or writable. Okay. So also delete, del, and if you call an attribute, so whether it's a function or variable, doesn't matter, it will actually remove that variable or function from the object. That's interesting. Not sure where that gets used, but interesting nonetheless. Can't say I've ever seen that. Let's see here. So scopes are determined statistically. They are used dynamically. At the time during execution, there are at least 3 nested scopes whose namespaces are directly accessible. The innermost scope, which is searched first, contains local names. The scopes of any enclosing functions which are searched starting with the nearest enclosing scope contains a non-local but also non-global names. The next to last scope contains the current module's global names, and the outermost scope, searched last in the namespace, is the namespace containing built-in names. Kardash, nice to see you. Hello there. Also, if you're new and stopping in to watch this stream today, please hit that like button. It really does help me out. All right, let's see. Let's read this special quirk right here. If no global or non-global statement is in effect, assignments to the name always go to the innermost scope, so it becomes part of whatever function, I guess, scope that you have. or object scope. Same is true for deletions. The global statement can be used to indicate the particular variables that live in the global scope and should be rebound there. The non-local statement indicates the particular variables live in the enclosing scope and should be rebound there. All right, so now we get to an example on 9.2. Hey, tax action, nice to have you back. All right. So we have this definition of a function called scope test, and it looks like there's a few other definitions inside of it, as well as just some statements and then something out of the scope of scope test. So the way this works is they went ahead to find all these, well, this function, and then a few more functions inside. They switch spam to certain things such as local spam, non-local spam, and global spam. What do I think about Linux? Well, let me take a moment and answer that question here. Well, a lot of my channel is based around Linux, so I do thoroughly enjoy messing with Linux and using it, programming on it. You know, I've been doing it for quite a few years now, and it's amazing how far Linux has come. So I really enjoy Linux in short. You can check out my channel, of course, to look at all sorts of videos about Linux and installs, help, tutorials, what have you, all on the channel. Moving on here. So what's the point of this whole entire deal here? So they're just showing us how as we make function calls and as we specify these non-local, global, what do they call them? I guess these are defining what bound the variable has. So is it part of the non-local scope, the local scope, or the global scope? And if we run through this real quick and just talk about it. So the first thing that's going to happen is you're going to call scope test. So scope test will actually define 3 more functions, and then it will set spam to equal test spam. And then it's going to call the function do local. So if we call do local, what will happen? Well, we go inside of do local, and spam is equal to local spam, right? But it's only local to this scope right here, meaning between where it's defined. So it's not going to get out of this function. Therefore, once you print a local assignment, it's going to print test spam. Let's make sure that's true. We go down here. After local assignment, right, it's going to post or print out test spam. So correct about that one. Great. And if we go to the second one here, so we've printed out something, we do the, we call the do non-local function. Well, what happens then? It goes into this function and says, hey, spam is non-local. Spam is equal to non-local spam. Therefore, since it's not local to this function just right here, right, it's going to come out of this scope and be part of the scope test scope. So once we print, I would expect spam to be equal to non-local spam. Is it? It sure is. So after non-local assignment, we assign non-local to spam. Non-local spam is printed out, and that's right here. It's a little confusing. There's a lot going on here, and they use a lot of names very similarly, so it's hard to kind of follow all this through, but hopefully we're following along. Do global. So now we've called all of this so far, and we're going to do global. And it's going to print after global assignment spam afterwards. So what does do global do? We'll go in here and look. Global spam, right? So spam is equal to global spam. Would you expect this to print out spam as global spam? Well, no, because this right here is not in global scope, right? It's actually in the scope of scope test. So since it's not out here, you're not going to see global spam. And let's make sure that's true. So we print out global assignment to what? After global assignment, non-local spam. So it just kept whatever the last non-local assignment was, which is defined in here. Finally, after we break out of this entire function, right, we've ran all our statements, we're going to print in global scope spam. Well, what's that going to be? You defined it as a global here, spam, and it's a global spam, so I would expect global spam to be spit out, and it sure is. Oh, Kardash, you're new to Linux. Well, that's awesome. It's got to be exciting. And thank you for the kind remarks. I try to be as helpful as possible, but sometimes it's hard to explain things, especially in Linux and especially in programming. So I'm glad to have you around the community. That's awesome. I hope you're getting a lot out of Linux, and I hope that you stick with it and learn a lot. There's a lot to learn about operating systems, and Linux is a great place to start learning that. All right, so we finally get something fun. Class definition syntax. So this means we can create a class if we know how to. And it's super simple, it seems like. You create a class, you put class in front of it, you name it whatever you want. It looks like they like doing camel case here with an uppercase in the first letter. So we have as many statements as we want. In the class name definition, you can see everything's indented, meaning it's part of the class. All right. It says here class definitions, like function definitions, def statements, must be executed before they have any effect. You could conceivably place a class definition in a branch of an if statement or inside of a function. So they're just telling you can define a class inside of different scopes. In practice, the statements inside of a class definition will usually be function definitions. By other statements are allowed and sometimes useful. We'll come back to this later. The function definitions inside a class normally have a peculiar form of argument list dictated by calling conventions of methods or for methods. Again, this is explained later. So it says when a class definition is entered, a new namespace is generated and is used in a local scope. Thus, all the assignments to the local variables in the new namespace, in particular, function definitions bind to the name of the new function here. All right. When a class definition is left normally via the end, a class object is created. This is basically a wrapper around the contents of the namespace created by the class definition. We'll learn more about class objects in the next section. All right, so class objects. And JavaScript too, yeah. I guess my opinion on JavaScript is, what do you plan on using it for? If you just want to do basic functions like manipulating data, interacting with operating systems, opening files, editing them, that type of stuff, I would say JavaScript is a no-go. But if you want to end up working with front-end development and websites or web development in general, let's say you want to develop a web application, yeah, JavaScript is very useful there. JavaScript is really tied to web programming. Oh, really? From Bosnia? Well, that's pretty cool. Well, your English is very good then. All right, so continuing on here. Hopefully that answered your question, Kardash. All right, so our first example of a class here. Let's read through this. So class, they defined it as my class. They set they just set I equal to a random number, and they define a function and pass the class in, self, and return hello world. So at least I assume that's what they do here. Self, I assume, calls the the object itself or the class itself. So then my class I and my class F are valid attribute references returning an integer and a function object respectively. Class attributes can also assign to, so you can change the value my class.I by assignment doc. Returning the doc string belonging to the class, a simple example class. So class instantiation uses a function notation. Very cool. So you can just use whatever variable you want. You don't have to use any keywords. You just call it like it's a function. So this is an instantiation, meaning a creation of the object of type my class. All right. So here they're saying they have this looks like the instantiation operation calling a class object creates an empty object. Many classes like to create objects with instances customized to a specific initial state. Therefore, a class may define a special method named init. Okay, so this in C and C++ is much like a constructor. Now, I'm sure it's used differently here in Python, but that's what it reminds me of. So they have this special function called init, which just sets up some initial state of the class. You can see what they do here is they create an empty list called self-data. So self meaning belonging to my class. So when a class defines a init method, class instantiation automatically invokes a init for the newly created class instance. Yeah, so much like a constructor. So when this is called, right, so when you instantiate the class my class, then init gets executed and it creates, it creates some sort of initial state. So let's go ahead and use this example real quick and check it out. So I have this. I'm just going to copy this over and let's run this. And what I want to do is I want to, let me print these out. And you can see we get 3.0 and negative 4.5. So let's, Anupam, nice to see you again. Thanks for coming along and watching the stream today. If you're new and stopping by, just go ahead and hit that like button for me. It really does help me out. We're talking about classes here. We're currently actually looking at our first class definition within a init function, much like in C++ a constructor, which allows you just to set up some information about the class when it's first created. All right. So what they did here is they called or created a class called complex. Now this is defined before they call that class because otherwise the scope will be wrong and then this won't know where class exists. The complex class exists. So on line 8 they actually instantiate the class. This is called instantiation, which just means creation, right? It's a complex word, get it, complex, of just saying created. Instantiation means created. So they create complex and they pass in 2 arguments, which it accepts 2 arguments as well as itself. It passes itself in. And then for itself, it actually creates 2 variables, one called R and one called I, and it attaches the arguments and saves them and stores them into R and I. So the real part, which is this 3.0, gets passed in, and imaginary part, negative 4.5, get passed in and saved here. Which this is interesting because negative 4.5 is not an imaginary number. Negative 4.5i, now that is an imaginary number. But since you can't put an I in a number, I think that's why they did it. But I think this is more appropriate. Hi there, Cyber King. Thanks for stopping by. I'm not making anything currently. What I'm doing is we're going through the python.org tutorial here, and it's about classes right now, and we're just kind of looking at how to define a class and how to use classes in Python. Okay, so if we, well, I changed that up a little bit, but so complex was called. Since it was called and it started creating an object called complex and it's saving it into X, that's our object X. We're going through this init function and passing in a couple arguments. We're going to save those arguments into self, which self is technically complex, the class. And since complex, the class, is now called X, you can reference x.r and x.i, which is technically the self.r and self.i. So this right here is a great way to, without specifically calling out the class, it's an easy way to just say, oh, reference this class, reference this object. It just makes things easier in the future, you'll see. So now we kind of understand what the init function does and how to create a class, as well as instantiate a class and even print out variables from that class. So it says instance objects, that's 9.3 here. What can we do with instance objects? The only operations understood by an instance object are attribute references. There are two kinds of valid attribute names, data attributes and methods. Data attributes correspond to instance variables in Smalltalk and to data members in C++. Okay, so data members, they're just, think of them as variables. That's what it is in C++. Data attributes need not to be declared like local variables. They spring into existence when they are first assigned to. For example, if X is the instance of my class created above, the following piece of code will print the value 16 without leaving a trace. Okay, so they say, okay, that makes sense. So all of a sudden, right, they didn't have a counter up here, right? So they just say XCounter. So that becomes part of the object. And it does something here on the object. So while it's less than 10, so from 0 to 9, XCounter is going to become XCounter times 2. So it goes 1 times 2, which is 2. And then it goes 2 times 2, which is 4, and so on and so forth. And it's going to go ahead and print that XCounter and then delete XCounter, meaning delete it from the object. So we can just add this simply in here, and let's go ahead and run it. As you can see, it printed out 16. So that would have been, well, let's start it at 1. I don't know why, but I expected this number to be a little bigger, but that's fine. 2 to this. It's 2 to the 4th power, but I thought we were going up to. All right, I'm missing something here. 16 doesn't seem like the right number, but I could be wrong because 1 times 2 is 2. XCounter is 1, so it's actually going to go 8 times through. 1 to 9, 8 times through. So I would have expected 2 to the 8th power, but yeah, I'm clearly missing something. Moving on, we get what this does. All it's trying to show us is we created X as a complex, right, class. And in that complex class, there was nothing defined as counter. And all of a sudden, we sprung counter into life as a object member or attribute, and we went ahead and did some function with the XCounter, and then finally we deleted the XCounter from the object, so it no longer exists in this object. So I bet if we try print XCounter, we might even get an error. And see, it says there's no attribute to counter, right? Since we deleted it, it's gone forever. Yeah, Anupam, I do understand that, but I was just expecting, it says counter. Oh, I know why. Yeah, XCounter is, yeah, it's only going to loop through 4 times because it's multiplying by 2. XCounter changes, therefore it's skipping in increments of 2. It was going to go between, 9 values or 8 values, and it's doing every other value, giving you 4. So 2 to the 4th power is 16. Thanks for that little hint. I think you jogged my memory at that point, and that makes sense. So it's going every 2 because it's multiplying by 2, and it's counting from 1 to 9, and that's technically 8 places, and it's only doing 4 of those. All right, moving on. The other kind of instance attribute reference is a method. A method is a function that belongs to an object. Okay, same thing as C and C++. They call their functions methods that exist in an object. So we'll just keep going. I understand that. Well, once I'm finished here, my plan, and I don't know how many people want to use this or not, but I think I'm going to go ahead and combine all of these tutorials together. That way someone can go ahead and follow them from beginning to end, and take out all the little fluff. So any place where we have questions or, dead space, I'm going to take that out, and I'm going to go ahead and try posting that. And the big reason I'm doing this is so other people can follow along, kind of understand how to go through these tutorials directly from, whoever created whatever language. So here we're doing Python. Read their documentation, understand their tutorials, and kind of has something to follow along with, because a lot of these are designed for people who have some prior knowledge of programming, and it can be very hard and intimidating to follow through unless you have someone else, kind of working with you. I always like working in groups, and I just thought it'd be kind of fun to kind of go over this as well as me learning Python myself. So that's kind of the plan there, tax action. And then eventually I'm going to go ahead and work on some projects with Python that I just want to work on, of course. And if anyone is interested in C and C++, I do have a full tutorial with 10 episodes on my channel for that. It goes from beginning to end of making a simple list program, which keeps track of a list of items for multiple users. And it goes through stuff like version control. It has debugging in it, how to set up your environment in Linux, actually, and run through how to make your own program. So usually a method is called right after it is bound. So x.f, f is the function, and it's got these parentheses because it is a function. In the my class example, this will return hello world. So my class, let's look back at that. My class. Right. See, they defined a function called f, and all it does is return hello world. Therefore, if you call this function, that's what it's going to return. X of f is equal to x.f. That's interesting. So you can It's almost, so you can define, it's almost like you're defining a pointer to a function. Hey, Pri, nice to have you on today. Glad you can join us. So this is just showing us you can kind of redefine how the function is called. So they did x.f without saying it's a direct function, so it's copying, it's I guess it's still considered an object. It's copying an object into x of f. Now it's referenced as x of f, and then while true, always and forever, print x of f, and then they actually say print use the function. So here's the object x of f. I'm accessing the function inside the object. Yeah, that's pretty cool. Just something to know. You can redefine the name of an object and then access that object or function. That's all. Class and instance variables. All right. Generally speaking, instance variables are for data unique to each instance, and class variables are for attributes and methods shared for or shared by all instances of the class. All this means is instance, let's see. So instance variables are unique to each object that's created. Class variables are shared amongst classes or objects. All right. So they have a class called dog. The kind of dog, well, every dog is a canine. And then they have what we saw before, this special function, which gets called on whenever you create a object of dog. And it goes in here and names the dog. And you're passing in the name. All right, so let's look at this example. D, so a new object D is equal to of a type called class dog. And they pass in, for the instantiation, this name, Fido. So we would expect that the name of the dog called D is Fido. Otherwise, E gets instantiated as a class of dog, but the name Buddy. So D kind, right, and E kind, that's shared amongst everybody. It's a canine. So both dogs are canines, but the name is unique. So we have a name, self, right, belongs to that instance, D or E, of dog. So D.name, you would expect Fido, and E.name, you would expect Buddy, because that's what we defined. Awesome tax action. I'm glad you're going to check that out. Yeah, it's been rising in popularity recently, so I hope it gets out to more people. It did take a while to create that whole series, but I wanted to cover quite a bit and kind of show everybody how to start from nothing and really advance the program to a full-fledged program with classes, multiple files, makefile, everything you could imagine that you would use in C and C++. The only thing I didn't touch on is pointers, just because it's a little complicated and convoluted, especially for beginners. Moving on to the next one, we have a class called dog. So now it's showing us the wrong way of doing something as opposed to the correct way of doing something. Reason this is wrong, right, is because you wouldn't expect every dog to be able to do the same trick. So they created an empty list here, and you can actually throw stuff into this list, right? A dog can have multiple tricks it can do. Whatever they say, roll over, play dead, whatever other things you can imagine, handshake, right? Well, This is incorrect because what this is saying is the dog that you're creating not only will never have tricks, but there's no tricks shared amongst every single dog. And you can see they say call add trick, right? And they append trick to this list, but once we call, right, d-tricks, so we would expect what are the tricks of Fido? That's Fido's tricks are d.tricks. Well, he can do both of these, but that's not what we wanted because we said Fido could only roll over and then Buddy could play dead. So why did it show us both? It's because of how we define this up here. This is incorrect. The correct way is go ahead and pull, you got to pull this down, right? These tricks into self tricks, meaning only tricks that belong to the object instantiated. And now it's correct. You can see that D tricks, which is Fido's tricks, roll over. And E tricks, he can play dead. So Buddy plays dead and Fido does roll over. So that's why the first time it was incorrect. The second time it is correct. And all they did was bring it down, and basically all you had to do is do the self tricks. And you can see in here, they just append the trick to self tricks. So they edit this, right? They add it to their list. I can see we have some newcomers. If you don't mind, go ahead and smash that like button for me. It really does help me out. We're just continuing going on through classes today with Python. And we're going to look at, let's see. So we've learned about creating classes. We've learned about how to use a init function to go ahead and specify some attributes that belong directly to whatever instantiation you created. And that's at the very beginning of creating the object and the proper way to use variables of the object itself. Random remarks. If the same attribute name occurs in both an instance and in a class, the attribute lookup prioritizes the instance. Okay. So let's see here. Class warehouse, and then we have two variables, purpose and region. And warehouse W1 is a warehouse. And then print both of these, right? The purpose and region. So it's a storage in west. And then W2 creates another warehouse and does W2 region east. Well, we went ahead and overwrote what was in region, which was west. And now when we print out region, it says storage east. So it's just saying it prioritizes this over what was in the class. Hey, how do you say that? Arva? Sorry if I mispronounced that. What do you need help with? Go ahead and print it in there. I'll see if I can get to it here during the stream. So let me read. Okay, this is interesting. So often the first argument of a method is called self. This is nothing more than a convention, okay? You don't really need self in there. So what they're referring to is like up here when they did self. You don't need it necessarily, but It's just a convention that they use. Note, however, that by not following that convention, your code may be less readable to other Python programmers, and is also conceivable that a class browser program might be written that relies upon a convention. Okay, so it's just saying it's something that everyone uses in Python, so use it. Simple as that. Oh, I gotcha. Well, I haven't got to my comments yet. I will be getting to them a little later once I finish this up. I'll go ahead and answer it then. So let's see here. What are they doing? They define a function outside of a class and return min. Okay. Class C. F, right? So they have I think they call this an attribute inside of the class, and that's a method because they called f equal to f1, and they defined another function called g, or method. They pass self in because that's just a convention that they use, and they return hello world. And then they say h, right? So h, that's a whole nother reference to g, which is this function. A lot going on here. So now f, g, and h, they're all known as attributes of a class C, right? Anything in here is an attribute. And consequently, they are all methods of instances of C. So like I said, they became all functions, methods. Note that this practice usually only serves to confuse the reader of the program. All right. Yeah, that's exactly right. They redefine G to be H. That's all. And they still have G available as well. So basically they have the same function twice. One called H, one called G, and they do the exact same thing, which is return hello world. Methods may call other methods by using method attributes of self-argument. So they have a class, and it's a bag. The bag can have data, and it initializes with some form of data, but doesn't pass anything in, just itself. So then they define an add, which actually adds stuff to the data if passed in. Add twice adds 2 sets of data. The only reason they can get away with this is because they have self. But self is calling add, right? Twice. That's all it does. And since add is part of bag, that's how they can call add. All right, now we're getting even more involved. Inheritance. So here, a class. So this is a derived class. And it's a derived class of base class. So this is where you pass in what class it's based off of. So anything belonging to the base class, well, the base class will have access to anything that's in, backwards. Derived class will have access to anything that's in the base class. So the base class name must be defined in a scope containing the derived class definition, in place of the base class name. Other arbitrary expressions are also allowed. This can be useful for example when the base class is defined in another module. So there could be a base class that exists in some other module. You can go ahead and pass the base class, or better yet, inherit by just saying the module name and the class name. So it's saying that when the object is created, the base class is remembered. This is used for resolving attribute references. If a requested attribute is not found in the class, the search proceeds to look in the base class. So if it can't find it in the derived class, it's going to go ahead up, because now the derived class has access to everything in the base class. It's going to go look through the base class next. So it uses anything from the derived class first and then moves its way up. So you can imagine having, I'm sure you can have a base class and then a derived class and another derived class of that last class, and keep going down the list, and it's just going to keep going up the list searching for whatever you're trying to access until it can't find it. So they're all virtual functions. Overriding method in a derived class may in fact want to extend rather than simply replace a base class method for the same. Gotcha. So instead of overriding methods inside of the classes and objects themselves, you can add on. That's all that's saying. So there is two built-in functions that work with inheritance. Use isInstance to check the instance type. So you can instance object int will be true only if object class is an int, or some class derived from it is an int. Use isSubclass to check if class inheritance is true. Okay, so you can tell whether it's a. You can check what the type of the instance is, and you can check whether or not a class is inherited, or it is the base class. Not sure where you'd use that, but it's available. So again, multiple inheritance. Oh, okay. So you can actually inherit multiple classes here. Sure. So you just have to specify the first base class, the second base class, the third base class, so on and so forth. So think of it much like I don't know, maybe a car and the powertrain. I mean, you can't have a powertrain with certain things without certain things, like wheels and axles and an engine, stuff like that. So you can make a derived class called powertrain, but the powertrain could have some bases, some important parts like the axle, engine, and yeah. All right, Tax Action. Thanks for stopping by. I'm glad you could watch, and I will catch you in the next one. What we are doing is we are just finishing up classes here in Python, just kind of trying to get an understanding. We've done inheritance, multiple inheritance, how to actually define classes, objects, so on and so forth. If you're new and stopping by to watch this stream, please hit the like button. It really does help me out. Also, think about subscribing to the channel, where I have plenty of Linux videos, as well as some programming videos, including Python and C and C++. All right, name mangling is helpful for letting subclasses override methods without breaking intra-class method calls, for example. So they have a class called method. They initialize method with they pass an iterable, and here they have, let's see, self items list, so an empty list of items, and self dot underscore underscore update. So all that is they're creating a private copy, right, of the original method called update. Then they define update, and update is an iterable they pass in, and they go from item through the iterable list, and they append those items in iterable to a item list inside of mapping. So class mapping subclass mapping, they define an update, right? Another update function, which has keys and values. And in here provides a new signature for update, but does not break init. All right. So this is just able to actually take a key value pair and dump it into item, or dump it into the item list, sorry. Without necessarily screwing up this function here. Because see, you have a private copy here, so you can call update, or you can call update. But if you instantiated a mapping subclass, it'll have all of this, but it will instead choose to use this update function instead of this one. But you can also access the original update function through underscore update, because it has a private copy. All right, some odds and ends. Sometimes it is useful to have a data type similar to Pascal record or C struct, so this is a structure. Bundling together a few named items, data items. An empty class definition will do nicely here. So they do class employee, they pass, meaning there's nothing belonging to an employee right now. And they create a new instance of employee, which is empty, right? An empty record. And now they're filling in fields by generating them on the spot. John.name, John.department, John.salary, and these stay alive until you delete them. Very easy way to go ahead and create a data structure. Like they say, this is much like a structure inside of C programming. Iterators. Right now you have probably noticed that most container objects can be looped over using a for statement. So for, and they're looping over a list, or I think this is a set, or this is a tuple. Can't remember exactly, but I got that probably backwards. This is a key value pair here, and this might be a dictionary. And this right here might be a tuple. And this right here might be I know this is a list. For character in 1, 2, 3, a string, print char. And for line in open my file. Okay, so we know we can do all of these. So I'm sure it's going to show us something about maybe an object. All right, so what do we got? So S is equal to ABC. It is equal to iterator of string iterator object at. So it's just showing you that if you called it directly, it's just an object. Next it, A. Next it, B. Next it. Okay, so next is a keyword that you can use in order to access the it object, which helps you iterate over objects. That's all that means. And if you go out of the scope of it, right? So you go A, B, C, you call it one too many times, you're going to break out. It's a good thing to know. They have that in C and C++ as well. The iterator. So having seen the mechanics behind the iterator protocol, it is easy to add iterator behavior to your classes. Define an iterator method, which returns an object with a next method it class defines next. Okay, so they have class reverse. They initially define an init self data, and data, they store data. Index, they store a length of data, and then they define an iterator, so that just returns itself, and a next function which returns the next iteration, and they even raise an exception here, stop iteration. And it goes backwards because it starts at the very beginning, the very end, I mean, and then subtracts one and returns the data in the current index from the end. So if they called a reverse, right, they're going to save this instantiation of the class reverse into rev, which is an object, and they're going to pass in spam. What's spam going to do? It's going to go ahead and store that into self data. It's also going to store how big the length of that spam is, so 4 characters. So it's going to save spam and 4 characters, or sorry, spam and an integer of 4. And then if you do iter rev, gotcha, it's going to say this is a reverse object. But if you go ahead and call for character in rev, right, it's going to use, it seems like, this iterative function here, which iterates through and prints the characters in reverse order. That's really cool. A lot to understand there, but all it's saying is you can make these special functions which allow you to specify how you want to iterate through your class or object. It's very useful to know because in this one, since it's a reverse, you don't want to just go in order from 0 to whatever. You actually want to go backwards and display the characters individually backwards. And they even put in this stop iteration, raising a exception, because if the index is 0, you don't want to iterate any more backwards, or else you're going to go into la la land. Well, I think we're getting really close here to finishing up. Finishing up classes here today. I hope everyone's enjoying this. This is a little bigger, but we only have 2 more sections here, so I really want to just go ahead and finish this. Generators are a simple and powerful tool for creating iterators. They are written like regular regular functions, but use the yield statement whenever they want to return data. That's cool. So you can use yield every time you want to return something, and you can also create an iterator very easily with this, as shows you. So it does for index in a range of the complete length -1, and then it says, well, I can't remember that. Go backwards in steps of 1, I think. And this also does the exact same thing that this did up here. So for character in reverse, right, call the reverse function of something that you pass in golf, you passed in golf. It started at the end and went backwards in 1 increment. And every time yield returned a every time reverse was called, right? They just keep calling this for every character. It returns the data and in the current index, and since we started at the end, went to the beginning, it just went ahead and printed everything out. All right, so I think That's just showing us another way to reverse characters and how to use iterations using yield. Something to know. That's all. They're just wanting us to know about it. So generator expressions. Here's where generators get more complex. I think we're getting out of the scope of classes and objects right now, but let's just go ahead and finish up 910. And we'll call it a day. Sum of I times I for I in range of 10. So that sum of squares. This makes sense. You go from what, 0 to, I can't remember if they include or not 10 in the range, but let's just say from 0 to 9, I in, and they keep incrementing, and for every time that they increment, they multiply I by I. Simple enough. And then everything, well, the I times I for the last iteration gets multiplied with the current iteration, and that's all summed together. Okay, so they have two different vectors, an x vector and a y vector. And then what they do here is, okay, this is the dot product, so this is multiplying matrices together. So that's an example of how to do it. Zip it up, apparently. And then in that zip, and I believe zip just increments over each individual item in a list. So they're incrementing over each of these individual items in both the x vector and the y vector, which is this list of numbers. And for both those numbers inside of x vector and y vector, so it's first going to get 10 and 7, 20 and 5, 30 and 3. It's going to multiply those two together, so 70, 100, and 90, right? I believe that all adds up to 260 at the end because it sums every time it multiplies those together. So it does 10 times 7, then adds that to 20 times 5, and adds that to 30 times 3. Yeah, I'm in incognito. That's how I usually do stuff anyway. Unique words set. So they're creating a set for word in line split. Ugh, I'm not even going to go through this. We already did this, except all they're doing is creating a list instead of reversing the characters and printing them directly out. They're just saving it into a list. They're just showing you, again, use range and start at the end of whatever data is being passed in, and simply increment back by 1 until, I assume this means until -1, where the data ends, and print out every single character into an individual index of a list called data, and it saves it in this list. So you got golf, and that turns into log. All right, well, that's it for classes here on the python.org tutorial. I hope you enjoyed this stream of going through the tutorial today. And next time, we are going to, I think we're getting close here. We're getting close to the end. We're taking a brief tour of the standard library. And in this brief tour, I think we actually have just different types of functions and stuff that we can use. We'll probably go through these pretty quick because without having a means to use these functions, they're not going to make much sense. And I think there's also chapter 11, which is part 2. So maybe we can make it through 2 parts next time. And I think this all goes up to like chapter 13. So we're getting very close to the end. Thanks for everyone who joined into the stream today. Make sure to check out the channel. Make sure to go ahead and like the video if you haven't already. I will catch you in the next one. Thanks for watching.